Hello everyone, welcome back to another video. Today we are going to have a look at the grade 12 paper 2 mathematics question paper, which is from 2022. The focus for today will be specifically for question 8, which is about circle geometry. I would like to advise you all to just have a look at the previous videos, which was focusing specifically on this topic, just to familiarize yourself with the theorems that we are going to use to answer this specific question. I'm also going to attach the links to the specific videos on the description of this video. Alright, let's get straight to the question. In question 8, we are given a diagram. They are saying that O is the center of this circle, and there is a cyclic quadrilateral in that circle, which is MNPR. And they are saying that Sn, this chord here, is the diameter, and also chord MS, chord MS, and OR are being drawn for this specific diagram. And then we're also given the angle 64 degrees. That is for M2. The first question is, we must calculate the value of angle P. So this is the angle of interest, angle P. So we are asked to calculate the value of angle P, number 8.1.1, angle P. What is the value for that angle? Alright, so to move back to our description, they told us that we have M, N, P, R, and they are saying that is a cyclic quad. For a cyclic quad, just to remind ourselves, we have specific theorems. The first one being that opposite angles of a cyclic quad, so if we look at M, at N here, and the opposite angle for that N, those angles are supplementary. What does supplementary mean? It means that if you have to add this angle and this angle, you have to get to a sum of 180. Contrary to complementary, when you say something is or the angles are complementary, it means that the addition of those two angles should give you a 90 degrees summation. So, and also there's various other theorems which are about cyclic quads, but today we're going to make use of this specific one. If we're asked to calculate the value of P, what is the angle opposite P in that same cyclic quad? P is not opposite N. P is directly opposite M2, and M2 is of value 64 degrees. But we know that these two angles, angle P plus angle M2, those two angles should add up to 180 degrees. The reason being, opposite angles of a cyclic quad, we can draw the cyclic quad, should sum to 180. So opposite angles, that's a sign of an angle of a cyclic quad, should sum up to 180 degrees. So we already know that now the sum of these should give us 180, but the angle of M2 is given as 64 degrees. So we can easily substitute that there. P plus 64 degrees is equal to 180 degrees. To find the value of P, we must take 64 to the other side. Therefore, we have P equals to 180 degrees minus 64 degrees, and the answer should be 112. 116. So the answer should be 116 degrees. You can also confirm on your side. So 116 degrees for the value of P, which makes sense Because if you had to look at the value of, or the angle P, it is kind of bigger in just by observing, it's bigger than the angle of M2. So those should add up to 180, and we've calculated it to be 116 degrees. All right, so the next question is asking us to calculate the value of M1. Where is M1? So we're asked to calculate the value of M1. Here is M1. So to find the value of M1, we already have the value of M2. And does M1 fall in that cyclic quad? No, the answer is no. So we need to observe our diagram even much deeper than what we did for the cyclic quad. But one thing you should notice is that M1, the angle M, the whole of M, so that's going to be M1 plus M2. So those two angles sit within this. So they told us that Sn is a diameter. So if you notice that these two angles are being subtended by that whole of that diameter, and exactly what you thought, we all know that angles subtended by a diameter are equal to 90 degrees. What does that all mean? We know that an angle at the center, so angle at center, there's a theorem that's about angle at center is twice the angle at circumference, but the trick to that is that those two angles must be either subtended by the same chord or the same arc. So if you look at the angle Sn, so this is a straight line, so it forms an angle of 180 degrees. This forms an angle of 180 degrees and is subtended by this arc. If you had to follow this arc S, and you see that arc, that same arc is subtending the angle M1 plus M2. So look at this arc and look at this angle here. That's the angle, and also look here, the angle 180. So that's just another way to verify that you understand what we mean by an angle subtended by a diameter is equal to 90 degrees. So we know that M1 plus M2 should be equal to 90 degrees. M1 plus M2 is equal to 90 degrees because that is half of 180. The reason is that these are angles subtended by diameter. They should equal to 90 degrees. The other explanation is that angle is an angle at a semicircle. Others can go to this route that I just explained to you, which is that an angle at center is twice the angle at the circumference. And at this point, angle at center is 180 degrees. The circumference should be half of that. All right, so how do we calculate the value of M1? Simple. M1, and we substitute the value of M2, which is 64 degrees. All right, so if we take the value of 64 degrees to that side, we have that M1 is equal to 90 minus 64 degrees. And you can calculate that to equal to 26 degrees. So the answer to that is 26 degrees. That's the value of M1. All right, so the last question. For the last question, we are asked to calculate the value of O1. O1, here's O1. What is the value for O1? So there are many routes to this one. We can either go for the fact that O1 plus O2 gives us 180 degrees. But do we have the value of O2? No. So that is going to be a little bit hard. But it's possible. O1, if you also notice, I just told you that there is a theorem that speaks to an angle at the center is twice the angle at the circumference. Do you notice that O1 and M1 are both subtended by this arc SR? And one thing that I've seen that tricks many people is to think that the theorem about the angle at center being twice the angle at the circumference, we always want to associate it with a chord, but that's not the case. It doesn't have to be a chord being drawn here. No, it can literally be that arc. Arc SR is subtending this angle at the center, which is O1. And that same arc is subtending this angle of M1. And O1 should be twice the angle at the circumference, which is M1. So we are going to trace this. Alright, so O1 is equal to 2 times M1. What is the reason? So O1 is twice M1. The reason is that angle at center is twice angle at circumference. Hopefully you can see that. Angle at center is twice the angle at circumference, and those two angles are subtended by arc SR. So an arc different from a chord. So RP, this part is a chord, this part that falls within the circumference is the chord. What is the arc? That's a chord and this is an arc. So what is the value of M1? M1 we've just calculated 2 times, it was 26 degrees, and that should give us 52. That is the answer for the angle O1. Thank you very much. Please leave any questions that you might have in the comment section below. Thank you.